Hey, hello, welcome back to SGLang Office Hour. Today we have Ligeng from NVIDIA. How are you, Ligeng?
Good. Nice to meet you, everyone.
So before we get started with the topic today, so I would love Ligeng to introduce himself to the audience. Maybe just like quickly share who you are and what you have been working with and stuff like that.
Okay, sure. Hi, everyone. I'm Ligeng Zhu. Yeah, so currently researcher at research scientist at NVIDIA Research. And I graduated from MIT and worked with Professor Song Han on efficient AI. And my recent topic includes the agents for L4, L2 to L4 levels automatic research and engineering. And I might also focus on the scalable and efficient engine harness and swarms. And I have published related papers and projects at NVR and MIT, and recent 10K submission citations this year. And today, I'm going to introduce our recent work on how to effectively transform our tokens into productivity, and includes the three researches: the KDA, the JetAutoResearch, and also quick examples on the Anthropic's take home, as well as the design principle and the future plans for the Humanize project.
That's amazing. So before we get into the topic today, so Ligan, can you quickly tell what is agent loop in high level?
Yeah, these are great questions. So nowadays, I believe many of you have already used the codex and the cloud code. And the thing is that, one very significant metric in here is that, so how long is the interval or the gap between your two prompts into the system? So previously, like in most of my workmates and the people around me, I noticed that they usually need to type or chat or give a command to the system, to the codex about every 10 minutes, every 20 minutes or half an hour. So so agents has already greatly boosted our productivity, but with single agent session, still you need to prompt into it, and it takes a long time to respond, and you have to frequently check it. But we want to maximize the token's productivity, and we want to set the recent things that we can type a single prompt and let the agents run for days, even to weeks, without drifting the origin goal. And to achieve this goal, we need the agent loops so that we change the input and output between agents and let the agent decide what is the next step. And with the agent loops, we can let the agent run for a very long time to fully unleash its ability and the potential power.
Sounds like a very interesting project. So now, Ligan, you have the stage. Thank you so much for
Okay.
sharing. Yeah.
Okay, yeah. So yeah, thanks for giving me the stage. And here, the topic I'm going to share today is advancing the token productivity with agent loops. And the main topic here is that how to effectively transform the tokens into the productivities. Before we dive into the details of the agent loops and the token productivity, we may want to have a quick overview of the AI coding. And AI coding actually has rapid very quickly in the last 5 or 6 years. And the codex, yes, the most popular codex in the OpenAI product, is actually already announced in 2021. And there's a lot of things happens in the 5 years. And the powers, the abilities, and the scope, and also the total foundation capability of the models has evolved so quickly. The power of scaling has brings more knowledge, longer context, better instruction flowing, and more accurate function calling, as well as more intelligent reasoning that allows us to build more intelligent LMs. And in April 2024, we are already at the dawn of the software AGI. And you can see the Cloud Code team has shipped a bunch of features in just 52 days. Even considers the team size is much smaller compared to the OpenAI and the GDM. And here is the thing. So the AI vibe coding has a lot of stages. From 2020 to 2022, which we call this complete era, which is just focus on the ghost text to finish the line by code you were currently typing, just like what we have as features in the JetBrains and also other old IDEs. And then from 2023, we have the and in 2024, there's one significant and important thing which we call the agentic shift from the assistants that suggest to agents that actually act, focus on the actions, running tasks, fixing bugs, and also manage deployment. And in 2025, we finally have the reasoning and multi-step agents. And with the reasoning, we can understand our task and decompose it very quickly. And from the mid-2025 to early 2026, we have tools that handle the entire engineering flow, from a ticket to a merged pull request. We also have multiple parallel agents cooperate as a team and group. And here is the thing. What's the difference from the reasoning to autonomous operations? And the key thing here for the autonomous operation is that we have an agentic loop. So agentic loop is something basically that we loop with the agents and LLMs. And the previous web coding, what we have is we have a single agent session, but many input prompts. But current auto coding is that we have many agent sessions, but we just have a single or very few prompts. The advantage of this is that you can make people less involved in the loop and let the agent decide how it is going to improve the whole framework and achieve the final goal. And the agent loop design, like the famous AutoResearch and the rough loop, the basic prototype is very simple. Basically, we human has a proposal, and some engineer target want to implement. And we have a builder that elements implement the feature, and also we have a reviewer to verify score. Until the verification has passed, the end will loop. And this changes to two different LMs and different agent sessions to work on the same goal. And these things can be only achieved with the CLI, not the GUI. That's why nowadays the cloud code and the codecs all moved from the GUI to the CLI. And such flexibility gives the agent the ability to fully unrelease its power and ability. So, and also based on the agent loop sessions, and Sihao, a current PhD and UCLA, and soon graduate. After his graduation, he will come to the NVIDIA Research as well. He proposed a very interesting project, it was called the Humanize. In the Humanize, he suggests that the agent loop is a bit like the real-world RL, so input from human, middle reward from the LM, and final judged by the human. And in this project, the Humanize, it propose like the iterations of perfections, and it has one build, one review, and begin with the mid-end in the mind. And the Humanize is actually an enhanced version of the AutoResearch, and this design is also very simple. So in the Humanize, it has three stages. So first stage is that when we want to have like a very simple thing, is like we want to generate a plan. For example, here we want to implement a KDA in CUDA given the reference in the FlashInfer repository. And we generate this plan and generate the plan to implement it. So Humanize will first read the draft to generate a concrete plan. And after it generates a concrete plan, you can first comment on the plan to give some hints and ask the agent to modify the plan according to your needs. And after the several iterations of the refinement, the human and agent are finally on the loop. The Humanize will then perform like a RLCR loop to run to the iterative interactions. So in the interactive implementations, the Humanize have very, very interesting design, which is that it asks the cloud code to implement the feature, and the codecs do the reviews. And until like the codecs thinks the current implementation is satisfied, the cloud code will move to the next action item. Otherwise, it will reduce the current items until the codecs think current implementation is good enough. And such an agent loop is very simple, but such a simple agent loop actually can do a lot of amazing things, which we will show later. And with the Humanize, a very simple and effective agent loop, we have shown some many interesting and impressive achievement. And the first thing we want to share is the KDA. Kernel developer agents for the Blackware, and it has achieved the top 3 performance at the FlashInfer Contest and MLSys 26. Okay, so in the kernel developer agents, basically its target is to write effective kernels, CUDA kernels for the recent popular operators in the LLM. And for the popular kernels, previously, if you want to write a fast and accurate kernel, you may have had to ask the CUDA expert to do the implementation. However, such implementation requires a lot of domain expertise, and you usually have to wait for a long time for the expert to do the implementation. And here is the things. Many people and researchers have previously studied and tried to use the kernel agent to improve the performance. However, previous performance is always not ideal. So things we notice here is that because in 2016, the web coding actually has 3 layers. One layer is called the model, which is Opus GPT DeepSeek Kimi, and another layer is the tool with the Cloud Code, Codex, and Open Code. The third layer here is actually the agent loop, such as the Humanize, AutoResearch, and the rough loop. In such a view, we notice that the agent is actually the model plus the tool, and harness is the tool plus the flow. And for different levels of the web coding, the agent's longest time the agent can run without drifting from the original goal is different. For example, like the model level API, it usually only takes 5 to 10 minutes to finish a query. And for a tool level API, for example, you type a prompt as a codex, and it will usually take like 30 minutes to hours to finish score. But for flow levels, we can extensively to increase the agent runtime from days to weeks without the drifting tool. And when we scale the running time from the days to weeks, something interesting happens. And then with the flow levels of web coding, we can actually build our kernel design agent. And the kernel design agent actually consists of the 3 parts. One is the Humanize, the long-running agents loops. The second part is the kernel wiki, a created implementation reference from the SGLang VLM and TRT-LM. And the third thing here is the NCU profile scale, which analyzes and details the roofline and performance trees. And noticing thing here is that we do not insert much human prior in the stage. What we did is only we launch the agent loop and ask the models what we want, and then let the agent and the model to automatically decide what's the next goal to do and to implement. And this actually brings us a very impressive performance. So the first thing is that we have the agent loop, we have a planning phase, and also the agent loop with a robust verification to ensure that there is no accuracy loss. And the second thing is the kernel wiki. We collect the PRs from famous repos, such as like PyTorch, Catalyst, FlashInfer, FlashAttention, SGLang, and VLM. And we use Cloud to generate a label and also abstract, summarize the skills and also the implementation techniques from each PR. And during the implementation, the agents can automatically decide whether it want to check the existing reference from local knowledge base. And the third technique is the NCO report skill. We ask the expert to profile the NCO report and find the potential errors and bubbles and underutilized parts. And based on these underutilized parts, we ask agents to do further improvement to improve such related weakness. And the performance here is quite impressive. You can see here we compare to the famous search baseline. You can see if you only launch with the model level approach, so the performance here you will only get 1.4 times near speed up. But if you switch from some model level approach to flow level approach, you can see the Humanize greatly boosts the performance by 2.7 times immediately. And with the kernel wiki and NCO report skill, we can first boost the performance by a large margin to get higher performance on the DeepSeek sparse attention top K kernel. And these implementations here gives us a very strong belief that we can use the agent loop to write kernels for most tasks. Oh, here analyze is Chinese, so I don't know how many audience here can read Chinese yet, but maybe we can skip this part. Yeah, go to the analyze, and if you are interested, I will show the slides later. You can check it and by your own. So and you can see here is that for the final results here is quite amazing. With the flow level approach, we can actually greatly boost the performance from the model level approach. And we have achieved the first place in the MOE track, second place in the DS track, and the third place in the GDN track. And you can see also we compare the performance with the agent assistant and the full agent track. The blue dots on the right is also the best result of the human with agent-assisted one. And as the purple dot on the right is full agent approach. You can see our initial results already achieve very good results compared to the MOE-based, compared to the human-based approach. And even on the MOE track, we are already rank 1. And so in the submission, we get 0.7 times speed up compared to the baseline, which is already fast, but still not beating the baseline and much less inferior compared to the human-based results. But after the results, we design better human agent loop methods and let the agent to running for a long time, and we can boost the performance by a large margin. And for the other two tracks, like the DSA and the GDN, we can also first boost the performance by a large margin. And notably here, the thing is that during the context, like for me personally, I haven't written a line of CUDA this year. And as the leading participant, Dongyun, he has only written around 400 lines of Triton in 2016. But with the help and the boost of the agent loops, we can also deliver comparable and competitive Blackwell kernels on the kernel contest track. Okay, yeah, here's our first work, and we have open sourced our GPU kernels as well as our agent loops for the context. You can scan the QR code if you're interested. Any questions or comments?
I think
okay, if no question,
1 minute delay. Yeah, we will say that to Q&A. Yeah.
Okay, great. And the second thing is that we will show the agents that explores open science problems, a showcase of the Anthropic take-home. So in the early this year, in the January, there is the Anthropic take-home challenge, which asks the interviewer to write a batch tree work computation on a virtual VIW plus SMD machine. So such a machine is very interesting because you may know that nowadays our CPU parallelism is based on SMD and our GPU parallelism is based on SMT, and both SMD and SMT they are like on each cycles you have a single instruction, but you can load the multiple data from different indexes. And VIW, which is a different hardware, that means that in each cycles you can load the different instructions. And this VIW plus SMD, which means this hardware, in each hardware cycle, you can load multiple instructions as well as multiple data. And this is very interesting because such a hardware programming model is very complex, and it's very hard to write an effective compiler to translate your implement computation into the hardware. And because of the programming difficulty, such a hardware is never massively produced and deployed in the real world. So there is almost no leakage in the pre-training or the post-training phase. And the goal of the Anthropic the interview here is not to test how the candidate familiar with the computer architecture and the parallel computation, but more about like how fast the candidate could design a harness to solve the issue. And here is the thing. In their January's blog post, they asked that if you can optimize to less than 1487 cycles, you can beat in the cloud best performance at launch. You can directly send an email to get an interview from the Anthropic. And here, if you use the model level agents, you definitely cannot achieve score. You can see here, You can see the stuff here is that if you use model level agents, then you will get a better result about 24,000, 2400, and that's almost the limit you can achieve. And if you use tool level agents, like you type the prompt in the codex and the cloud code, it can soon and immediately boost the performance from 1800 to 1700, something like that. And after the April 2026, we have the Gore feature from the codex and the cloud code. So this can greatly boost the performance to achieve less cycles than the Anthropic's original interview bar. But if you have used the Humanize, even with Humanize 1.5, you can achieve like 20-50 cycles already at just a single run. And if you can run with the Humanize 1.5 and 2.0, you can even achieve near 1,000 cycles and even less than 1,000 cycles solution, which is far better than the Anthropic's interview bar. And the theoretical limit to read all the data is around 930 cycles. So we are already very close to the theoretical limit here. And here is the thing we notice that, so actually for different levels of the Anthropic take-home, we can see that the key takeaway here is that you should use the flow level agents to solve an open science problem. If you merely use the model level or tool level agents, you can never pass the cloud operators. You can never pass the Anthropic's interview bar. And as long as you have the flow level agents, you can greatly boost the final performance of your solution. And this is because not because you have better model or better tool, just because you have better flows that manages and utilize the agents. And here we also plot an ablation here is that we ask the agents to run at most 48 hours. And we find that so different line here is that so different flow. And the CC means cloud code. And CX means codex. We notice that the 7 methods on the performance take-home kernel is very different. So different flows actually leads to different convergence rate, and also different convergence rates lead to final different performance. So which means that previously, like almost all communities, we want the better model, larger model, higher TPS model, but we didn't pay much attention to how to use the tokens wisely and cleverly. So here is the thing we want to share the insights and emphasize that the methodology of how to use the tokens is as much as important how to produce high quality tokens. And the takeaway from the Anthropic take-home is that so web coding nowadays is consistent of 3 parts: the model, the tool, and the flow. If you miss any piece of the components, your web coding experience will suffer greatly. And when all people use the same model, the GPT operators, and the same tool, codex, and cloud code, flow is actually the key to improve the performance of agentic system. Okay, yeah, and here is some takeaway. So we have upgraded our workflow from autocomplete to autonomous operations. If you are still at the early area of the web coding, you definitely should upgrade your workflow. And key note takeaway today is that you should trust your agents as trust your lab mates, your workmates, your interns. You should give him the full access and the full approval, and talk him with the natural language as much as possible, rather than interactive coding and micromanagement. And in such a takeaway, as long as the final reward is clear, the metric can be evaluated. You should trust the agent and let it explore instead of inserting and feeding a lot of human price into it. And agent loop is a core approach to minimize human efforts as well as to boost the productivity of the agents. And I have a claim is that so now since this year 2016, so your big O of your productivity is highly related to the big O of your consumer tokens. Okay, so any questions or comments?
Ligeng, we have one question from YouTube. The question is, I have a question about agent loop. Sorry, I have a so how long does it take to refine your loop, such as kernel, wiki material that you feed to the agent loop to get a good result?
This is a very good question. So if you just use agent loop as Humanize without any kind of wiki, you can get like our measured results like 2.7 times speed up in just an overnight. So I would say like around 8 to 12 hours. And if you integrate everything, so the Humanize kernel wiki and NCU profile, so the total runtime is about 48 hours to 60 hours. Yeah, about 2 days or 2.5 days, sometime like that.
Okay, I think that's the question we have so far.
Okay, so I will continue. And next things I'm going to share is about the Humanize past, present, and the future. How does Humanize from an automated idea factory to realization? So we have like a belief that the human LMs are much more knowledgeable than the human, because like it has 30 at least 30 trillion tokens for the pre-training, and also we notice that so LMs remember much more tricks and tips, and their contexts are much longer than humans. So almost all commercial models, it has more than 400,000 to 1 million context lengths, so which is far beyond what a human can achieve. And let alone the agents can run 24 hours a week, and also does not need to rest and easy to replicate and to scale up. But in our real world, what we actually get is that we've noticed that so agents fails frequently, and then which is very frustrating. So key divergence also stuff here is that so we have said many misalignment between human and the agents. So the first thing is that so once the Humanize 1.0 has a such complex propose and discuss design in the initial stage, because that we find that many agent failures actually doesn't come from the agent ability, but from the misaligned initiative. Like today, we have an office hour at SGLang, and if we just talk to the SGLang's PM, just said, okay, let's have an office hour today. Please book our meeting room. And such a simple sentence has many ambiguities. For example, when will the office hour be hosted? And will the office hour be online or offline? Should we book some meeting rooms for the video streaming or just the in-person closed door? And should we support multiple platforms? And should the meetings be hosted in the English or in the Chinese? And so many ambiguities here will make the agents confused and doesn't know which version actually the human wants. That's why we want to have the codex and have a very detailed and very specific discussion with human to make sure every stage, every detail, the human and the agents are on the same page. Otherwise, it will implement the goal, but not just give you the results human wants. It will have a heavy and a deep think to ensure that the agents really understands what the human wants, and the humans also make sure and ensure that the agents totally understand its initiative. And in the Humanize 1.0 design, we notice that if you have a fast implementation, which is called web coding, and if we have a very weak alignment, you didn't check what you really want, and if you have zero judgment, then you will get a very fast, wrong, and garbage work. Your code base quality will degrade very quickly. And in Humanize 1.0, it first proposed a quiz to check human really understand what is the task it delegates, and to make sure the human understands that he is proposing a reasonable target to the agent system. And the second part of the Humanize is the design and there's the review loop. And the design and the review loop here is that so we notice that we all know that the agents are very smart, and the smart agents are tricky, and the talent also means lazy. They are very easy to satisfy and trick itself, so the current implementation is best. So the thing here is that we have to make sure that the implementations doesn't involve any reward hacking, only tricky methods. And to achieve this, a very good idea, a talent view, is that we ask the models to do a peer review. So we ask the Cloud Code to implement the feature and Codex to review the feature. So it must to be peer reviewed before merged into the main code base and proceed the next action bullet. This is very similar like our GitHub. If you have a PR to a SGLang, so you have to make sure your PR is peer reviewed by your workmates. You cannot click approve for yourself. And with the two designs here, is that so we can actually first we make sure the agents and humans are greatly aligned on the same page. And second thing is that we have a peer reviewed system to make sure the implementation doesn't hack the reward or involve some dirty things. So it can make sure we do not have such a goal drifting, and we can see the agent is always on the right path. That's why with Humanize, you can let the agent run stably from hours to days, even to weeks. And the Humanize 1.0 design is highly motivated by the way human collaborates on the GitHub. And also you can see we have a very good comparison inside. You can imagine that the model is a clever and top new graduate students a company would just hell. And the tour is the clusters, office rooms, chairs, monitor, the printers, HR, and the company infra provided to so clever top new grads. And the flow is the proper way of the management, the organization design, and the company cultures that motivates and encourages the new grads to do a great project. And also, if we believe that the agents nowadays become more like human, that if we need some management for talent students, then we also need such a management for talent agents. And I have a strong belief that the flow would be the most critical part for the 2016 and 2027 research efforts to maximize the token's productivity. And also such a design is also quietly delivered in the cloud code, which is called workflow, which means that inside the Anthropic, they will have something similar to the Humanize 1.0. And in the Humanize 1.0, we have said, okay, we have like a flow that just works. But now we come to the next question is that does different tasks require the same flow on the different flow? And my experience during the daily developer routine, I believe that so different tasks would require different flow. That's why I propose Humanize 2.0 that allows the user to write their own flows. And from 1.0 is that the flow just works, and 2.0 we want to set an IR that build flows and enables flows to call flows. And if you have written something like our VM, here is some primitive we would like to build the Humanize 2.0 on. And with such a programming language interface, we can greatly shorten and make the implementation much easier. Like here is that if in the Humanize 1.0's RLCL example, we have around 700 lines of bash to implement the feature. And with the new design Humanize 2.0 IR, we can greatly shorten and reduce it to the 19 lines. And also it makes the design and propose a new flow so very easy. For example, if we want to have 5-way parallel builder review, or if we want to have 100 ideal generate stream and parallel evaluate, we can all write this in the new IRs in just less than 20 lines to make the things very easy and simple to developer and also to scale. And also in the Humanize 2.0, we want to like platforms for IRs, and also we want to interesting to tap into flows that generate flows. And here is also some roadmap for the Humanize V1, V2 to the V3. And basically the main principle here is that we found that so first, the flow is the key change that differentiates and diffs the people's real usage and the productivity you can get from the same model and the same tool. A better flow means a better productivity. And the Humanize way is that from a flow that just works, we want to extend it to a platform that build flows. And also we want to further in the future to extend it to the agents that generate this flow. And this is a roadmap for the Humanize. And I think that's all my presentations. It's about the time. So thanks for your time. Any questions or comments?
Yeah, I think let's start the Q&A. Let's switch to the Q&A slide. Yes. Yeah. First of all, thank you so much, Ligeng, for being here and sharing this slide. I really like that you used me as the example at the Humanize part. Yeah. Let's get started with the question that we have. Okay. Yeah, we have question from Zhang Tai from YouTube asking how can we extend Humanize to other accelerators such as AMD? Ligeng, can you hear us?
Yeah, please.
Oh, yes. The question again is how can we extend Humanize to the other accelerators such as AMD?
It's not a problem to ask that question for NVIDIA employee, right? Yeah, but I would say the main goal is it should be similar. So as long as your target have a very clear and vivid evaluation metric, you can also insert or define such problem in a human like agent loop, right? You just have like a very goal and very high level target and let the agent to design and to propose how such a scope can be implemented. And as long as maybe for example like writing kernels, as long as you can pass the kernel accuracy and speed test, so you can do whatever you want. Yeah, it's similar to like I think it's a process for writing AMD kernels and the CUDA kernels should be similar, but just for AMD kernels, you may consume much more tokens because the weakness of the AMD's compiler and the ROCm infrastructure.
Great. Next question from Wenxuan. Why does Codex plus Go outperform Humanize on the Anthropic stay home?
Does it? I don't think so, because our results actually came from some Humanize's principle, not from the code, also Codex.
Yeah, maybe move to the next question. Yeah, let's see. Hua Peng asks, hi again, thanks for your teaching. I have one question. If we need to connect tools like NSys to profile, can we call them in agent loop or we just profile via Python print?
Also, it's a good thing. So actually, in our experience, so we just provide like a skill.md. We provide us how to profile with the NCU and NCs, something like profiling with the profiling tool. We summarize it as a skill and let the agent to decide how to call it. So in our design pipeline, so the NCU profile part is print out the information in a JSON format, and this agent will automatically read and parse it.
Amazing. Next question from Jackson. With the help of Humanize, does the descriptive and detailed prompts still matter? Or Humanize will also do good with a short prompt that has only the end goal?
Good questions. Yeah, so previously your prompt so I would do a comparison. So when in the early LM era, like in the ChatGPT in 2023, your prompt is actually very important, and there is actually one thing called prompt engineering. But nowadays, voice prompt engineering is no longer that important because we have one thing is called reasoning. So you can think of reasoning is something like auto prompting. Yeah, let's LM to find the most suitable and proper prompt for the LM itself. And the thing is somehow similar in the agent flow. So the agent flow is that you plan, also your draft can be very simple. You can just say implement the KDA in CUDA and assess your draft. Very, very simple. Yeah, and but the thing is that when you have such a simple draft, the Humanize 1.0 will discuss and extend. It will first expand the draft to a very concrete and detailed outline, and discuss with human and make sure every details, every outlines, every sub-bullets, every action items is aligned with the human's initiative. And after the implementation outline is aligned with human. So your original draft is no longer that important, because for every details, every important things, so you already checked it with Humanize.
This is good. Next question from Louis. How to contribute to this project?
Contribute? Oh,
I mean,
okay. Humanize is an open source project, and we always welcome various types of contributions. Yeah, and also if you have built something really cool, so if you want to use and if you have some difficulty or problems while using the Humanize, you can directly open an issue on the GitHub, and also we will consider to create a Slack channel further. Yeah, and if you have something built very cool with the Humanize and want to advertise with Humanize, yeah, just open a PR. Yeah, and we would like to discuss with you and add it to our README.
I think there's also another user, audience also asking about how to use the contributor Humanize. I think they probably asking for like how do they search this repo and
okay.
Yeah.
So Humanize is a project already released on the GitHub. Yeah, you can just search Sihao and Humanize, and Google should help you to find this project.
I see. Amazing. Yeah. Next question. We have a question from Wings. You can organize skills into workflow. What's the significant difference between skill organized workflow compared to Humanize generated flow?
Yeah, great questions. So you can imagine things that so skills. So the idea or concept of skill is that they are still under a single agent session. So when I say it's a single agent session is that you open the codex, you type until you clear all the messages. So this part is a single skill session, single agent session. You can imagine that. So you can design and develop different types of skills, different skills with different functionalities, and but no matter what type of skill you design, they're still under a single agent session. And with a single agent session, the problem is that so you cannot keep it running for a long while without to like it run like an agent session to run for weeks and days without drifting. But in the Humanize, we call it flow. So why is called flow, not the skills? Because like in flow, you will have multiple agent sessions to run interactively. And especially in the Humanize, we not only have multiple agent sessions, so different agent sessions also has different models. Like here on the figure top bottom right, we have the code to the implementation and the Humanize and the codex to the review. So you can imagine that there are totally different agent sessions with different input and system prompts, and the base models are from different pre-training and post-training and alignment. So this is not something you can achieve with the skill part.
All right. Next question. From an infrastructure inference framework perspective, what are the current bottlenecks and future direction for optimizing agent workflow?
So here, I would say there are two things. So for the Humanize 1.0, they are mostly designed for the deliverable engineering works. And so this task basically is most for like a software engineering problems with a clear and fast evaluation. But the thing is that we actually have a lot of more open problems. So something just like writing the kernels. So if you just want to write a correct kernel, then it's the engineer problem. But if you want to write a fast kernel that achieves near as speed of light performance, sometimes it's a research problem, and you do not know which direction is good. So actually, for different type of workloads, we may need a different type of the flows. And currently, it seems that the Humanize 1.0 is a fixed workflow for all tasks. But for in the Humanize 2.0, we want to give the users the ability to define and to customize different flows for different tasks. Yeah, and we believe that for it's kind of like for different tasks, if you can customize and study a concrete and specific flow, you will have a better performance than a general flow. And that would be the main developer concept and focus for the Humanize 2.0.
Next question. So for Changyi, how to create a good skill? Can this be done with the agent? Because for kernel agent, the NCU skill does help a lot.
I would say yes, but the NCU skill actually doesn't bring some major improvement. The major improvement still comes from the Humanize. Yeah, and also you can see on the MLSys track, there is something called some MCS track. So a lot of people using the K-search and also AutoResearch with NCU, but on general like 3 tracks, so the agentic loop with NCU skill brings the best performance. If you just use the AutoResearch plus NCU, you will get like inferior and less optimal kernels.
Okay, last 2 questions. So first one, also from Jackson's, why Kodak is being chosen as the reviewer and Claude instead as the executor? Yeah.
Yeah, this is very interesting. We tried, so actually Sihao did a lot of operations on this part, and he found that, so actually, so Codex is currently the best model to serve as a reviewer, because it's global view and personality and some insights. So the overall performance, if you switch the role, like use the Codex to do the builder and the Cloud Code do the reviewer, so whole engineering performance would suffer and degrade by a large margin. So we do not know what type of tricks and pre-trained secrets OpenAI has put on the Codex. But from our practice, we all have noticed that Codex is the best reviewer. And we highly recommend to follow our setting to use Codex as reviewer.
Great. One final question from the community. So from JJ, what some example of workflows beside Humanize?
Sorry, what?
I think he or she asked what are some example of workflow beside Humanize? Maybe agent loops.
Yeah, some agent loops, some Anthropic, and we will provide more examples on GitHub once Humanize 2.0 becomes stable. We will soon open source this workflow on GitHub.
I see. Okay, let's wrap up the Q&A today. But I also have one final question for Ligeng. So what if someone from SGLang community, he or she would love to use Humanize to contribute to SGLang? Do you have any suggestion or where to start, things like that?
I think you can contact the core contributor of SGLang called Bbuff. He has already started to use Humanize to boost the kernel performance, also to optimize some system bottlenecks for many SGLang operators and also system design. You can ping him and ask so what's his current insights on the agent loops and how he actually uses agent loop in his daily development. And yeah, let's have a chat with the Bbuff, and you will find many useful and interesting topics to start with.
Yeah, maybe one day we could invite him for another office hour session.
Yeah, totally agree.
Yeah, of course. Thank you so much. I know there's a lot of questions on YouTube and X as well. Please join SGLang Slack to post questions. Ligeng is also in the Slack channel as well. Feel free to ask him question there. So let's wrap the live stream. So if you haven't start SGLang, please go to the link and follow SGLang on GitHub, and also go to X and follow LMC Sorg. So everything news about SGLang will be there. This is the 2 QR code for that. Okay. Also, we have a developing the AI course about SGLang. It's a little bit over 1 hour. We basically talk about all the basic fundamental thing with SGLang. Here's the QR code for that. And also we have a Luba calendar. So we put all our offline meetup and also office after like this there. Please go there and subscribe. And thank you so much for being here today. Thank you, Ligeng, to share agent loops. This is such a great content. Thank you so much.
Thanks for the hosting. See you.
Yeah, see you next time.